Hello and welcome to what will undoubtedly be the longest video you've ever watched about binary numbers. So why am I making this challenge here? So I made a coding challenge number 117 called the 7-segment display. And what I was doing was creating a visual JavaScript, HTML, canvas version of a 7-segment display. And to do that, I had some weird code in there. Val greater than shift ampersand 1. And that code right up there, made no sense to anybody. And I tried to explain it, but I got a lot of comments saying I didn't get what this was. So this is bit shifting and bit masking. So before I can even get into that, I thought, let's take a deep breath. And let's just enjoy and go backwards in a time, days of yore, when we didn't have anything but binary numbers. And we had to program everything in binary numbers. I don't know, this never happened for me, but I could imagine there was a time where this really happened. So this is a coding challenge where I will explain what binary numbers are, and then I will create a sketch, P5.js sketch in JavaScript that converts a binary number to a decimal number. Okay, so maybe you're even asking right now, what is a binary number? What is a decimal number? So before I can even answer that, we have to talk about this idea of base. Base is a term that refers to the number of possibilities in a counting system, in a number system. So base 2, or binary, there are only two possibilities, a 0 or a 1. Base 10, deca, or decimal, has 10 possibilities, 0 through 9. There are other well-known numbering systems that get used often. Probably the one you see in computing the most is base 16, or hexadecimal. And this actually has 16 possible digits, 0 through 9, and also A through F. So when you see something like this in CSS, like FF00FF, this is hexadecimal encoding. This FF in decimal is 255. This 00 in decimal is 0. This FF is 255. So this is the color. This is a representation of the color red of 255, 0 of green, and blue 255. So anyway, so this kind of encoding of information exists. And by the way, in my 7-segment display, there were hexadecimal representations of what should be displayed on the 7-segment display. Okay, so hexadecimal is interesting. I'm not going to do hexadecimal conversion in this video, but it's important to realize like these are maybe some that you see. I think like base 8 is used for like some file systems, but you can make up anything. Like if you have base 4, you just have 4 possibilities, maybe 0, 1, 2, or 3. And when I say possibilities, this defines how you count. And by the way, historically, there are all sorts of alternative ways of counting. I believe, I was looking at the Aztecs used maybe units of like 0, then 20, then 40, then 800, then 8,000. There's like, these were and those were, instead of digits, there were actually like drawings of what, but so anyway, so you can look that up. Somebody will make a nice explainer YouTube video about counting systems. But if we have base 2, this means there are only 2 possibilities. So let's use base 10 decimal because we understand that 10 fingers, 10 toes. That's why base 10 is the convention. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? Because once we get to 9, we've run out of possibilities in a single digit. So we switch to 0, and then the next digit over, the tens unit, becomes a 1. This is what kids learn in elementary school in counting in groups of 10, hundreds units, etc. All right, so but if I were doing this in binary, I would say 0, then I would say 1, and then I have run out of digits. I have no more digits left. So I have to say 1, 0, and then 1, 1, and then 1, 0, 0, then 1, 0, 1, 1, 1, 1. I'm totally like, this is the worst drawing ever. And then 1, 0, 0, 0. Did I get that right? No, I totally did not. 1, 0, 0, 1, 0, 1, 1, 1, 0, then 1, 1, 1, and then 1, 0, 0, 0. Oh, this is hard. Okay, let me match up some things for you. So something that's really interesting here is 1, matches up with 1. 1, 0 matches up with 2. 1, 0, 0 matches up with 4. 5, 6, 7. 1, 0, 0, 0, 0 matches up with 8. Notice that when there is only the leading digit 1 and everything else is a 0, there's a pattern here. 1, 2, 4, 8. Maybe now you could imagine what 1, 0, 0, 0, 0 is going to be. How about 16? Whoops, sorry, 16. I should put that over here. 1, 2, 4, 8, 16. These numbers are doubling. So in fact, each one of these digits in binary represents not like the tens, the twos. So with a 1, this is actually 1. This is actually 2 to the 0 power. 2, this is 2 to the 1 power. This is 2 squared, 2 to the 3rd power. We're doubling. So this is, by the way, the algorithm that I need to write in my code to convert from binary representation to decimal representation. Are you ready to do that? I'm ready. So one thing I want to show you first is you can actually, you don't need to write your own algorithm to do this conversion. This is built into the way that computers work. And actually, JavaScript has several helper functions that'll do this for you. I think if I say, for example, equals 0b, if I have a variable that's equals 0b, I can put any encoding. So like, what if I put 1, 1, 1, 1, 1, 1, 1, 1? Now actually the value of, that's actually 255. So this is, I can actually hard code a number in binary by saying 0b. I can also use this parse int function. So if I say parse int and give it a string like 255, just converts it, the string, to a number. But I can do things like say parse int 110 and then give it a radix, or this is another word for base, and say like, what is the value, the integer value, the decimal integer value of 110 in base 2, right? It's 6. In base, if it were base 10, obviously it's 110. So this will actually be done for you just through that parse int function. But let's go and actually write our own algorithm for this. And yes, there is a bell ringing. And let's go to the web editor. So let's just assume for the sake of argument that the binary numbers that I want to work with are going to be strings. So I am going to make a number, and I'm going to make it a binary number. And there's a thing about like when you have 8 bits, that's kind of important here, right? Each one of these is referred to as a bit. Each spot in a binary number is a bit. When you have 8 of them, that's a byte. And so this has to do with how things are stored in the computer's memory, right? Everything ultimately in the depths of your computer is stored in binary format, and the amount of space it takes up is the number of bytes or kilobytes or gigabytes, etc., terabytes. But I'm going to waste a lot of space and encode my binary number as a string. So let's just try something really simple, like 100, and we know that should be 4, right? 0, 1, 1, 0. No, that's not 4. Yeah, it is 4. I lost my mind for a second there, right? This is 0, this is 1, this is 2, this is 3, this is 4. So we should get, if we do this right, we'll get 4. Okay, now I want to write a function. I'm going to call it binary to decimal. It'll take in any arbitrary value, which is a string, and we could make this much more generic. So, by the way, as a challenge to you, what if you made a function like this, which is just number converter? It takes a number and 2 base, a base and a second base. So here's the number in a given base, give it back to me in another base. It'll be generic. That's a challenge for you to do now or later or whenever you want. Okay, so the thing that I need to do is I need to loop through I equals 0, I is less than value.length. So if it's a string, I'm going to loop through the string 1 character at a time. So for each character, the way to convert it is to add up all of the 2's. So for example, 101 is 5 because it is 100 plus 001 is 101. And this is 4, and this is 1, so 101 is 5. So if I just start here and take the first digit multiplied by 2, and take the second digit multiplied by 1, the second digit multiplied by 2, the third digit multiplied by 4, add all those things together, and by the way, it's not just 1, 2, 4, it's 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3. So it's the exponent that's counting up. So I'm going to say sum plus equal power, and now I need to get this value. So I need to get the 0 or the 1. So I'm going to say the bit equals value car at I. Now here's the thing. This is an interesting question here. What is I when it starts at 0? I is actually a string representation. This is the 0 index. So even though I want to do the conversion by starting over here, I'm actually over here. So I actually want to get to the end of I want to start from the end of the array. Not the array, the end of the string. And a quick way that I can do that is by saying val.length minus I minus 1. Right? If there are 3 digits, I have 210. Not 012, 210. So 3 minus I minus 1. So sum equals power of 2 to the bit. And I need to make this a number. So I'll just use parse int because it's a string. And then let's just say console.log sum. And I think we're done, sort of. Console.log sum. And let's see. Let's do binary to decimal val. And actually, so this should return num, sorry. And, oh, there we go, 4. Let's test some other ones out. Let's add another one. 6. Let's try 1, 0, 1, 0, 0. This is a byte, right? If all the ones are on in a byte, right, everything is on. 8 bits is a byte, and if everything is a 1, what do we get? Okay, I need one more. Wait, what's going on? Oh, something is wrong. No, this isn't right. I've made a mistake. This code is not correct at all. So remember, each digit represents a 1, a 2, a 4, 2 to the ith power. I actually even said that sometime earlier I said 2 to the ith power. Maybe only in my head. So what I'm actually doing is taking that bit and multiplying it. Now, of course, it's a string, so I have to convert it, the string value. Now, this is what I'm looking to do. And now, 255. There we go. Boy, somehow I was getting some right answers by accident. So that should be 4. This should be 5. Yep. Whoops, I can't have 2's there. That should be 18. So I should probably write some error handling, right? Because actually, this would actually work. If I put a 3 in there, it's going to give me a number, but it makes no sense at all. So, and once again, what I wanted to show was that 8 bits all on gives me 255. And in fact, this is why we see, again, the range. You can store 256 possibilities in a single byte. A byte being 8 bits, 256 in decimal, or 2 digits in hexadecimal. All right, I'm getting some messages from the chat saying that maybe it would be more intuitive to run the loop backwards. So yes, but then it's 6 of one, half dozen of the other as far as I'm concerned, because I either have to invert it here or I have to invert it here. So I don't know which would be more. I mean, I could have a counter. So, I could do this, counter equals 0, and I could run the loop backwards and then increase the counter. But I don't know. I'm going to stick with what I have. All right. Now, I said this was going to be a long one, and I'm going to let it just be a long one. If you want to stick around and keep watching, you could go do something else. But what I'm going to do is now make this interactive. So I want to make something where I can actually click here, and I can turn on and off bits and see the conversion live. So let's figure out how we're going to do that. So I think I want to use some object-oriented programming. And I am going to make a class. I'm going to add another JavaScript file called bit.js. And I am going to make a bit class. And the bit class is going to have and let me take off this auto refresh for right now. It's going to have an x. It's going to have an x and a y. And a width, like a size. Maybe I'll make it a circle. So it's going to have like a diameter. I'll use a circle to represent each bit. And then it's going to have a state, right? Its state is going to be on or off. Then I'm going to have a show function, or render I could call it, where I'm going to say stroke 255. Let's make the outline white. And should it be, I don't know, I can never figure this out. Is black on, white on? I don't know. Maybe I should make it red and blue. We'll figure it out. We'll see how it looks. So I'm going to say draw an ellipse at this.x, this dot y, this dot diameter, and its fill is going to be 255 times this dot state. So in this case, it would be white if it's on. So what I want to do now is make an array, and let's just use 8. We'll do a byte. And actually, so I could call this a byte. Well, that's probably like a bad word for me to use because maybe that's reserved somewhere in JavaScript. But let's say I equals 0, I is less than 8, I plus plus. And let's make a bit equals a new bit at I times. So let's say I want to fit all 8 across in my, and I could use DOM elements or something that's going to be easier to interact with, but I'm just going to draw them as circles. So I am going to say I need to calculate a width, which is the width of the canvas divided by 8. So I'm going to say its x value is I times width, its y value will be at 50, and its diameter will be w. And I'm going to say byte index I equals that bit. And I guess I don't need a separate variable here. I'll just do this. And then I want to say here, I want to say byte index I dot show. So what do we got? Oh, let me turn back on auto refresh. And I've got some errors. Show is undefined. I see a show function. Oh, wait, whoops. I put these in the wrong place. The creation of them has to be in setup, and this should go in draw. Nope, stop, don't. All right, bit is not defined. Oh, of course, I forgot that if I'm adding another JavaScript class, I need to make sure I reference it from my HTML file. And now we're seeing, and if all of them have a state of on, I'm not seeing anything. So let's see. Oh, I've got to pass in the arguments, x, y, d. So right now I want to set the arguments based on this. There we go. There they are. There's all my bits. And maybe I want to offset them a little bit. And maybe I actually want like this to be, their diameter to be like have a little buffer in it. Whoops. There we go. So this is looking nice. There are my bits. Thank you very much. Oh, I'm excited about this. This is going to be good. And now if I take the state and like state 0, there we go. So now let's make the state. Let's actually also initialize the state. I'm just going to write that in a separate, I'm going to set state, and I'm going to actually say num.car at I. So I'm going to use the character, I'm going to use the individual character there to set the state of the particular bit. Now, set state is not a function because I need to add that in here. And I'm going to say set state, state, and I'm going to say this dot state equals, and I'll add parse int in here just to make sure it's a number. And now, what's going on? Set state. is not a function. Oh, byte is not, of course. Byte index I dot set state. There we go. So now, as I change values in here, it turns those bits on and off. Okay, we're getting somewhere. Now what I want to do is I'm going to add a decimal. I'm going to say decimal p. Decimal p equals create p. What am I doing? Create p. And then in the draw loop, and it's silly that I have a draw loop here. I don't need to continue to draw, but that's something that I can revise later. I'm going to say, where's that function, binary to decimal? Binary to decimal. I'm going to say decimal p, HTML, binary to decimal num. And so now we should see it says undefined. Ooh. Oh, because it's console logging it. I want to return some. Okay, 182. Now you can barely see that. So let me go to my CSS for a second and add a color. And guess what? I'm going to use hexadecimal. Will it actually do it? No, I can use 3 Fs because it'll. But let's use 6 to do RGB, and let's also make the font size like much bigger. Okay, so now, and let's actually make this a just, it's got this extra, because it's a paragraph element. Actually, this is so silly, but I'm going to make it a div, just so it shows up here. Okay, so now, this is not interactive, but I can do this. And it does look inverted, right? This really looks like on, off, on, the way that I've kind of drawn this. Somehow the black color looks like I've turned it on. So, I could probably make the background much darker. Like if I made the background like 51. Yeah, so maybe this look, I don't know. It's so confusing. What if I made, I don't know which is which. You tell me. My visual design skills are kind of a disaster. But if I go back to this, but anyway, whichever way I think it is, I could actually just say 255 minus this. And now, right, now it is colored black when it is on. And I could say 1010. 1001, we can see 169. Okay, should I make this interactive? I mean, I've gone on for way too long already. Because I need to make this interactive. Do you know why? Because the whole point of doing this was to talk about bit shifting and bit masking, and I'm going to get to that. That I'll do in a separate video. Let's make this interactive. So what do I need here? I need some sort of function to see if this bit contains a point. So what I need to do is calculate the distance between this point and its x and y. And then if the distance is less than the radius, which is the diameter divided by 2, and it's this dot diameter. And I'm going to call this toggle. I'm actually just going to, I'm going to make this the toggle function. Then I'm going to say this dot state equals now. If the state is a 0, I want it to be a 1. If it's a 1, I want it to be a 0. What's a nice way of doing that? I mean, I could write an if statement. People are giving me great suggestions like +1 modulus 2 to the power of -1. I think I'm just going to admit to myself that really what I meant was for this to be true or false. So the state's going to be false. And when I say set state, I'm going to do parse Boolean. Is that a function in JavaScript? Let's see if it is. And then I can say not this dot state. Parse Boolean is not defined. There's no parse Boolean? What if I do Boolean? There we go. Okay, so Boolean is like a function, I guess, or that will convert that to this. And then here, what I want to do is I could just say if this dot state fill 0, and of course this is rather awkward, but I don't care. This is how I like to write code. There we go. This is no good. Oh, you know what? Those are strings. So this needs to actually say parse int. There we go. Okay, we're back. We're back, baby. Okay, now this Boy, there's lots of things you could improve, right? All right, now what I can do is make these interactive. So I can now add the mouse pressed function. And I can just say for, and I can loop through again. Once again, I can loop through, and this should really be byte.length. I can do this, and I can loop through all of them. And I can say toggle, whoops, no. And I can just call toggle with the mouse coordinates. So it's toggling, the toggling is working, but it's not updating. Ooh, why is it not updating? Because I am converting the string. My function converts a string. So I could do something like I could make the binary, the decimal version of the number out of the array of bit objects, but I think what might actually work nicely here is for to make the string out of it. So what if what I do now is I say in here, I'm going to say, I'm just going to use that same variable, num equals an empty string. And then I'm going to say num plus equal, this is in setup, sorry, in draw, plus equal, now I want to have a 0 or a 1, because if I say this byte index I dot state, so this is where I have to use it, but I have to embrace the ternary operator. It's something that I have never natively really understood. It's like never fit into my brain. But there's this thing called ternary operator, and it looks like this. The condition, and if the condition is true, this is the result. If it's false, this is the result. We can make this happen right now. We can use that ternary operator. The condition is actually just byte index I dot state. Then I need the question mark, and this is so nice. I just need to have, if it's true, a 1 or a 0, it's false. I need to say recreate that string. Whoa, look, it's going crazy. There we go. Look at this. Now, so lovely. Let's go. We did it. Everybody, we did it. I made a binary thing that you can click on bits and convert it to a binary number. Now, here's the thing. Oh boy, you, the creative person watching, if you made it to the end of this video, wow. You really are something. Thank you. I can't believe it, because this was ridiculously long-winded to just explain binary numbers. But you now have the opportunity to make something creative here. What if you could make a clock that displays the time in binary? Maybe you could actually also show the hexadecimal value. You could actually make this a form content editable that you could convert backwards. How do you convert? This is a thought experiment for you. I can come back and do another video. But how do you convert not from binary to decimal? How would you convert from decimal to binary? And I'll give you a hint. It has to do with division and the remainder, I think. There's so many things you could do. You could make a more interactive version. You could make a counter that's sort of, this would be fun to have this like count up in binary. But that's kind of like the clock. You'll color, other ways of visualizing it. You'll come up with something. I know you will. You always do. Thank you so much for watching this coding challenge. And I remember at the beginning when I said the whole point of this was talking about bit shifting and bit masking. I will come back and I will do that. So that will be in a separate challenge. I'm going to add some buttons for shifting and masking.